Okay, our sources of ocean pollution. The first one's going to be human activities on land. Oil tankers that have spills, or like the BP oil, Deepwater Oil Horizon, get a lot of publicity for the oil in the ocean, but actually over twice that amount comes from just shore activities, from regular runoff from the roads, or even from washing the tankers once they are in port. But it's the normal operation of the wells, unloading and loading the oil tankers, leaks from pipelines, that has a lot more impact on the amount of oil than the spills, because the spills happen so rarely, even though when they do, they are catastrophic. Almost half of the oil reaching the ocean is what's being dumped on the ground or poured down the drain, and these are all activities that are happening on land. Even things like changing motor oil, cars leaking on the roads. Now, the effects that these spills do have can be pretty catastrophic for the ecosystems. We have volatile organic compounds, or VOCs, in the oil that can kill the aquatic organisms immediately, especially if you have larvae. And then, of course, you have the oil tars that get on the feathers and fur. You see the commercials where they take Dawn and go out and clean them, which is actually what they do, because just like the commercial says, it cuts grease. It's about the only way that they can remove the tars from the organisms. Things that we can do to clean up oil spills: we have floating booms that they put to contain the oil, and that's because oil is less dense and it floats on the surface, and so that keeps the oil from moving further. They can use absorbent pads to soak it up on the beaches. Now, you're still going to have some absorption into the ground, but that can get a pretty good amount of the oil off the surface. Putting in coagulating agents, which causes the oil to clump together, and that makes it easier to pick up. Or dispersing agents, like using Dawn to disperse the oil on the animal skin and fur. And then they've started using oil-degrading microbes, or bacteria, that pretty much just eats and breaks down the oil. All right, some of the things that we can do to try to control pollution is through passing laws and actually enforcing those laws. And then also ensuring that everybody has an opportunity to have clean drinking water. And part of that is treating our water. So the Clean Water Act in 1977 it used to be called the Federal Water Pollution Control Act, but its main idea is to control the quality of water. So that's water in our rivers, lakes, aquifers, coastal waters. It has been amended several times, but its main goals are to cut down on the amount of pollution that is discharged into our waterways, and also to make sure that those same waterways are safe for us to swim in, but also for the fish and aquatic organisms that live there. EPA is the group that monitors and sets what those national limits for point sources are. Remember, point source pollution is pollution where we know where it comes from. We know the source. So industrial waste, sewage treatment facilities, that can be controlled. It is unlawful for anybody to discharge any pollutant from a point source into any of those bodies of water unless they have a permit from the EPA. All right, the Safe Drinking Water Act is another act that was passed. It was originally in 1974. And you don't need to memorize the years. You just need to know the gist of what the acts are doing and what their main goal is. But this is the one that is geared towards public drinking water. So there are federal standards that each water treatment plant has to follow. Now, the state standards can be higher than that, and it too has been amended several times. But the EPA, once again, is the body that sets the standards for drinking water, and they oversee the states for anybody that supplies drinking water. So that's not just the treatment facility, but anything that could potentially be drinking water. So if it's a river that feeds into a reservoir that provides drinking water, that would fall under that umbrella as well. So springs, groundwater, anything that serves more than 25 people is considered to be under the Safe Drinking Water Act. Now, laws that protect groundwater. These are generally laws that deal with hazardous waste, like the Resource Conservation and Recovery Act, or RCRA for short, deals with the disposal of hazardous waste. And so there are a set of regulations on how they have to be monitored and disposed of to help prevent groundwater contamination. The Safe Drinking Water Act also has some provisions that protect the underground aquifers. There are other laws that are related to pesticides or mining, and we'll talk about brownfields and Superfund when we get into domestic waste that also can help protect the groundwater. Now, we've looked at wastewater treatment, but water treatment is what we do on the front end. When we take water from a reservoir, for example, and I'll just briefly go through this. The first thing they do is add a coagulant that takes all of the solids that are in the water, causes them to clump together. So as it goes through a filter, some of those are screened out. It goes into a sedimentation tank where any solids that are left are going to sink down to the bottom. Then it's filtered once again. Now, if you look in this filter tank, there is sand and charcoal, and that's going to filter out pretty much what is left of the water. So if you're using reservoir water that's, kind of dirty in color, by the time it gets through this filtration and comes out, it is clear and clean and ready to drink. The last stage is to add chlorine, and most water treatment facilities will add fluoride as well, and that's just to help especially with children, to help their teeth grow strong and to protect your teeth. But the chlorine prevents bacteria growth in the water, which is why drinking water, or public drinking water, is very safe. Now, sewage treatment, after you use the water in your house, it has to be treated as well. If you are on a well system, like you get your drinking water from the groundwater, then you're going to have a septic tank for your waste. So your sewage goes into your septic tank where the solids settle out, and then the water's put back into the ground, what is called a leach field or drain field, and it is naturally purified as it seeps back through the ground. We had one of these in our backyard growing up, and I remember over this leach field, our grass was greener than it was anywhere else in the yard. Now, wastewater treatment plants, if you're on city water, you don't have a septic tank. Your water goes in the sewer, and it goes to a wastewater treatment plant. Now, the first stage in wastewater treatment is called primary treatment, and that's where they just remove the large objects and suspended solids, or what is called primary sludge. Secondary treatment is where they remove any of the bacteria and almost all of the organic waste. Now, all of our wastewater treatment plants here in Wake County and in Raleigh go through primary and secondary. Some wastewater treatment plants go through advanced treatment, and that removes the inorganic nutrients, the phosphates and nitrates, which we know can cause eutrophication. Once the water has been treated, then it's usually put back into a river that goes downstream and then becomes somebody else's drinking water. Chlorine is also added to wastewater, and that once again helps get rid of the bacteria. So here's kind of what a wastewater treatment looks like. Now notice at every stage they're removing sludge, which are the solids. The sludge is dried, and then it's just taken off either to agricultural land or to a landfill. Now, they don't use sewage sludge on an agricultural field that grows food for humans. They might for livestock or for ethanol. So here's what the sludge look like when it's added to a field. So some of it's used as fertilizers, a lot of it's used in landfills, some of it's even burned, but it can be toxic and cause health problems. There are natural ways to treat sewage. We can use natural artificial wetlands, which have the bacteria that break down. But similar to the wastewater treatment plants, they have sedimentation tanks where that allows the solids to settle out and become sludge. The liquid's put into oxidation ponds where you have aerobic bacteria that break down the material. Wetlands can also break down wastes, and when they're, during part of the year at least when they're wet, they release the water slowly, but they also help recharge the groundwater and our nursery grounds for a lot of our aquatic organisms. Now, the problem is over 50% of our wetlands in the U.S. have disappeared, and that can be for development, mineral exploration, agriculture, various reasons. And restoration is not always successful because it's almost impossible to figure out that complex relationship between the hydrology, the sediments, the plants in the area. It is done through mitigation, so we talked about how that's a trade-off approach. If you destroy or damage a wetland in one area, you can trade off by improving one in another area. So kind of, if you destroy a wetland, you've got to create a wetland. And that's it for today.